So pH and acids and bases, okay? pH scale is 0 to 14, okay? pH of less than 7 equals acid, okay? pH equals 7 equals neutral. pH of greater than 7 equals alkali, base. Okay? You normally measure pH with the universal indicator paper, or pH meter, okay? You get various indicators like methyl orange, which is it's red. The pH color changes red when it's below pH 3.1 and yellow above pH 3.4. You get phenylphthalein, which is colorless below pH 8.3 and pink above pH 10. And you get bromoethanol blue, which is yellow below pH 6 and blue above pH 7.6. And you get thymolphthalein, which is colorless below 9.2 and blue above 10.5. Okay, that's details which you pick up from using them. So yeah, water equals pH 7, okay? Because water splits up into aqueous, okay? Actually, that's liquid. Okay, water liquid, it dissociates into an equal number of hydrogen and hydroxide ions, which are in aqueous solution. And this is this means water dissociating to the ions, and they're continuously reforming into the water molecules. So it means the reactions are, you get dissociation and reformation continuously occurring. So all three species occur. You get water, hydrogen ions and hydroxide ions occurring simultaneously, okay? And it's pH 7 because the number of hydrogen ions equals the number of hydroxide ions, okay? And it's reversible. So yeah, the number of hydrogen ions, or the concentration, is equal to the concentration of hydroxide ions, okay? So yeah, you get examples of acids include hydrochloric acid, okay, which breaks up into hydrogen ion plus chlorine ion, okay. You get sulfuric acid, breaks up into H plus plus SO4 negative. You get nitric acid, which breaks up into okay, these are aqueous. Okay. And these are liquids. These are examples of acids. Hydrochloric acid, sulfuric, these are also strong acids which means the single arrow means you get total complete dissociation 100% from hydrochloric acid molecule into the two ions. So all this breaks up into these and you get lots of hydrogen ions. So these are strong acids, okay? There's also the ethanoic acid, the carboxylic acids like methanoic acid, ethanoic acid, propanoic acid, butanoic acid, which are weaker acids. So you get okay, so that's again aqueous. Liquid, okay, so the hydrogen, the proton comes off this, so you get the ethanoic acid. This applies to methanoic acid, propanoic, butanoic, pentanoic, hexanoic acid, and so on. It partially dissociates into hydrogen ions and the ethanoate ion. So you also get these reforming back to the complete molecule. So this is why this is a weak acid, okay? That's a weak acid because it's not complete dissociation, whereas these are strong because you get 100% breakup, okay? So yeah, there's also bases as well. Strong and weak bases exist. So yeah, I'll go with that. So bases, so you get sodium hydroxide becomes sodium plus OH negative, okay? That's aqueous liquid, okay? Sodium hydroxide, actually that would be a solid. It would be you'd put it into water actually. You dissociate, you dissolve it. So and barium hydroxide, okay, so that breaks up into barium ion plus 2. So these are strong, okay, that's a strong base, complete 100% dissociation to sodium and hydroxide ions. This is a strong base, and also this one is also a strong base. Okay, and these are solids dissolved in water. Okay, so these are very corrosive. I mentioned in the video in the world's most powerful acids, alkalis and bases are very corrosive. Yeah, hydrochloric acid, sulfuric acid, nitric acid, plus sodium hydroxide, lithium hydroxide. These are all very dangerous, corrosive. You must never touch them with your fingers. Always wear gloves, use spatulas, pipette. If you want to see what the pH is, stick some indicator paper and I use a pH meter. But gloves, pipettes, spatulas only, okay? Keep acids like hydrochloric acid, sulfuric acid in bottles with the caps on, and probably in fume covers, because they let off fumes which are not very nice. So yeah, they are corrosive and dangerous, okay? So yeah, these are bases. You also get weaker bases. I won't go into weaker bases here. So yeah, these are aqueous. Okay. I think I will come back to, I'll do the formation of and neutralization next. Okay.